Hello, this is a tutorial video for stoichiometric calculations. This video specifically is for a mole-to-mole calculation. So we'll be doing a few videos for the stoichiometry unit on different conversions. And you have this in your notes, and you also got this little slip of paper in class, which will help you to go through all of these different types of calculations for stoichiometry. And so what you want to do is use this handout to figure out what you are given in the problem and what you are trying to solve. So depending on where you're starting and where you're ending, you're going to need some different conversion factors. So for this particular problem, we're doing a mole-to-mole problem. So the question is asking us if we have 5.49 moles of oxygen, how many moles of water could be produced? And if we look here, so since we're going from moles of one thing to moles of another, we're starting with moles of something, moles of X, and we're converting to moles of a different substance or moles of Y. And you could really use this either way. If you said, oh, we're starting with moles of Y and going to moles of X, same thing. But in order to move from moles of X to moles of Y, convert from moles of one thing to moles of another, we have to use the mole ratio from the balanced chemical equation. And this is going to be the case for any stoichiometry problem. You need to have a balanced chemical equation to do any type of stoichiometry. Okay, we need that relationship with the coefficients from the balanced chemical equation. All right, so for this mole-to-mole problem, we're starting with this number here. So that's how I'm going to start out my calculation. And then we're going to set up our conversion factor using some dimensional analysis. So according to our cheat sheet here, we need to use the mole ratio from the chemical equation in our conversion factor. And since I have moles of O2 in the top here, I know that it's going to go in the bottom here. And what I'm trying to solve for is moles of H2O. So since this is a mole ratio, we're going to have moles on top and moles on bottom, but they're going to be of different substances. So I want to put moles of H2O here on the top because that's what I want to have my answer be in the end. Okay, so now that we've gotten the units set up correctly, we need to figure out what that mole ratio is. Okay, so we need a mole ratio, and we're going to get the mole ratio from the chemical equation. So we need to look at our chemical equation here, and we're pulling out the coefficients that are in this equation. So for moles of H2O, according to the balanced chemical equation, there are 2 moles of H2O, so then we'll put a 2 here. And then the moles of O2, which we need for the bottom, there's no number here, which means that there's actually an invisible 1. Okay, so we'll put a 1 here for moles of O2. So these numbers came from the balanced chemical equation. And now that we've done that, our moles of O2 can cancel. And that is all we need to do to get to moles of H2O. Notice we have the units we want. So now this is just going to be typing it into our calculator. And we need to follow sig fig rules. So we'll do 5.49. Top numbers you'll multiply, bottom numbers you'll divide. Since this is a 1, we don't really need to do it. So we'll do 5.49 times 2 equals this number, 10.98. But following sig fig rules, we did multiplication and division. So we're limited to 3 sig figs because there are 3 sig figs here. So this is going to be rounded to, if we cut this off after 1, 2, 3 sig figs, we need to cut it off after the 9, but there's an 8 there, so we need to round up. So it's going to be 11.0 to get to 3 sig figs. And the units are moles of H2O. All right, so that is the first mole-to-mole problem. So we started with moles of O2, converted to moles of H2O. The way we did that was by using the balanced chemical equation to get our mole ratio.